Hello guys, we keep doing vectors and vector addition, and here is applications. Okay, so we considered several problems mostly connected with geometry. However, we also discussed the problem when he or she swimming somewhere or running, and on top of that there is the strong wind, probably the river flow, and we trying to find out the general the resultant speed or resultant displacement. So here is also we covered a simple triangle rule in order how to find the resultant vector for two ones. Okay, we actually discuss how to define magnitude. In case of right triangle, it's pretty easy. In case of like scalene triangle, you need to use an property theorem like Cosine Rule. For example, if you know like two sides and the angle between them, you'll be able to find the other side of the triangle. Okay, so right now we're going to consider some variance problems involving vectors, and that's the game that's real application when you have probably river flow, you have the velocity in calm water, and you simply trying to find resultant motion, resultant displacement, or resultant velocity for the object. All right, so let's consider the first one. That's the bearing problem, and I'll explain you why actually you need to apply variance here. So the ship traveling at 35 kilometers on a course of 105, and it encounters a current of 5 kilometers per hour in direction 15 degrees. So you need to find the actual speed and direction of the ship. Alright, so that's definitely a task involving bearings. So this course of motion as well as direction of the current, you need to have some reference direction. It might be x, y set. So for example, you can set up y and x, and from, let's say, x-axis, you want to define 105 degrees. Yeah, it's somewhere here. 105, that's going to be direction of the ship, so velocity of the ship simply. And from that, you also need to set up the river, so 15 degrees from the horizontal x-axis, but it's not convenient, For these purposes, the bearings was exactly designed for, okay? For these purposes, we can use bearings. So I just remind you, bearings is simply the angle that arrange with the vector of motion, like it might be displacement, it might be like velocity. So no matter which vector you use, which physical quantity you use to measure angle from the north direction, so that's the bearings. Okay, so you have the north direction, and from there you're trying to measure in a clockwise direction the angle using protractor, for example. I'm not going to use any tool, not ruler, and I'm not going to use protractor, so I'll do it by my eye. But on exams, guys, you need to use protractor, you need to use the proper scaling. I showed it, you were showing it before in my previous videos about how to actually make a scale and how to convert from scale units into real units. Okay, so here I'll just show you the main steps, and you try to do it more precise than me because I don't have any tool there. Alright, so we first set up the starting point where the ship traveling at 35, or just current point where it's right now. So, and we set up the north direction from there. So let's say this is the north direction, from where we are going to set up 35 km per hour as the vector on course 105 degrees from there. So this is 90 degrees, so I'm going to set up a bit more, and I set up 35 degrees vector. Let it be pretty long, like that. Of course, one more time, I remind you that you need to use proper scaling. Let's say 1 centimeter stays for every 10 kilometers per hour. So you've got 3.5 in this case. Okay. So And for angles, you need to use protractor. So that's the angle of 105 in a clockwise direction. So we set up degree measures from north direction, basically bearings, and then 35 kilometers per hour, km per hour. That's the velocity for the ship, all right? Now it encounters with a current of 5 kilometers in direction 15. So what to do next? We're going to set up in this point, because we're going to use head to tail rule, so it's reasonably to set up in this point. I just a little prolong here. Let's set up in this point. So let's say that's the end or the tip of the previous vector of velocity of the ship, and we set up again the north direction. It's here, from where we are going to measure 15 degrees angle. So it's slightly here. So that's why for the river flow, because it's 5, actually 7 times less than your vector for the ship, or you can use just simply half centimeters according to our scale chosen. So I set up this angle here. Okay, so this is the vector 5, and that stays for the river, 5 kilometers per hour, and that's the vector for the river flow. So 15 degrees here. All right, how to determine the resultant velocity? You need to start with the very start of the first vector and end up in the end of the last vector. In this case we have 2, so we simply use a triangle rule. So we are going to connect those 2 points. Okay, so 15 degrees, now it's overlapped. Anyway, we'll try to maybe reset up. Okay, so that's the angle of 15 degrees. Okay, so we've got the resultant vector for the ship. I put res, that indicates resultant vector. And what we're going to do, we just need to simply set up the equality for vector addition. So resultant vector is actually equal to, so we've got vector for Vs for the ship, and we add up with the vector of the river. Okay, but technically, just you remember, you cannot 35 add with 5 because it's wrong, right? So for this case, we need to determine the angle in the triangle between, let's say, 2 vectors, vector of the ship and vector of the river. So because right now we don't have enough data, we don't even know that this triangle is a right angle, so we need to prove that. Okay, so that's why the problem is about how to define angles. Okay, so we know that's this angle, the total angle from north direction bearings to 35, which is velocity of the ship, is 105. But we know that this, we actually can set up, let me see what we actually can set up. We need to find the angle between vectors. So actually, ideally, is to find that angle first. Let's say this is the angle theta. Why? Because if you know theta, you can add with 15 degrees, and hence you can figure out the angle between 2 vectors, Vs and Vr. Okay, so how to determine? So we've got north direction. Basically, if you prolong, we've got 2 parallel lines, right? Because north direction represented by 2 parallel lines, and that goes through 2 points over there. And that vector Vs is the second segment. Okay, it goes that way. So looks like angle theta is the same as angle here, right? So in total, let's calculate how many degrees it represents. So that's also theta, right? That's the rule about two parallel lines and a second line. So we've got two angles corresponding to each other. Okay, they're equal. So in total, we've got this angle to be 180. So we can write that 180 degrees is simply 105 plus angle theta. Okay, and from where we can find the angle theta in degrees is the difference 180 and 105. So turns out to be 75 degrees. So if we know the angle theta now is 75 degrees, on top of that, if we add angle 15 degrees, we got the angle between VS and VR. So that's the total angle here. Okay, so angle theta, which is 75 plus 15, will give us the angle. So that's the angle between the vector VS and vector VR. So hence, in total, we understand it's 90 degrees. So we prove that triangle, I just one more time draw it, vector VS, I draw vector VR, and the angle, resultant angle between them is 90 degrees. So hence, triangle that we have arranged by V resultant and VR and VS is right angle. So if we connect that, we've got that this triangle is a right angle. So we can apply the rule in order to find hypotenuse. So how to find V resultant is basically hypotenuse, right? It's hype in this triangle. So we can say that, I just set up here, so that V resultant is square root of Vs squared plus VR squared, which is simply, if we plug the values, we'll find out that it's simply 35 squared, and on top of that we need to add 5 squared. Now let's go back to calculators and just simply calculate. Okay, what we've got that the resultant vector is square root of, so 35 squared and plus 25, which is 5 squared, and we've got around 35.36 to 2 decimal places. Okay, so we defined that the vector for resultant is slightly more than 35 and it's hypotenuse, so in full correspondence. Okay, but actually that's the actual speed, so we define the actual speed, but we need also to define direction. Okay, so how to define direction? So that what we can do actually, so we can probably set up, let's say, can we can try to define angle here, and if we know this angle, let's say angle X, we just simply subtract from 105 and hence we can find the variance of V resultant. Okay, so the problem is that if we know angle X, we can find out the angle for V resultant. So for this case, I will use triangle. So my goal is to define angle X, and I know two sides, two legs basically for the right angle triangle, VS and VR. So we've got triangle with sides 35 and 5 as the bottom, and from where we can find the angle X is basically a tangent. So I will set up the tangent for angle X, which is VS, VR basically, over VS. Yes, that's opposite sides to adjacent. So VS becomes adjacent, VR becomes the opposite side. Okay, so let's plug the values. It's 5 to 35, which can be cancelled to 1 to 7. Okay, and from where we can find x is simply 10 minus 1 of 1 over 7. Okay, so let's try to do. Again, we just gonna use calculator, your second set, tangent minus 1 over 7. Okay, and you'll get around 8.13 degrees. Okay, so that's why now we know the angle x, which is 8.13 degrees. How to find the variance of the resultant? So basically, how to find this angle is simply 1 of 5 minus angle x. So that's why the variance for the resultant is going to be 105 minus this angle x that we recently found. And let's subtract. So we're going to subtract this angle from 105, and it gives us 96.87 to 2 decimal place. Okay, so that's the resultant variance for VS. Okay, sorry, for V resultant. That's the resultant variance for that. And we actually determined the length of this vector, which is 35.36. The units for that, of course, kilometers per hour. Okay, so guys, you understand that that's mostly about the angle properties. We used the two parallel lines in the second line in order to find the resultant vector between the resultant angle between two vectors, and hence we established that this sort of triangle is the right angle. What if it's not? What if this triangle is not? So what to do in this case? So if it's not a right angle, so let's say that this is not 90 degrees, in this case you need to apply cosine rule. I'll just show you quickly, and probably for next problems in next video we'll apply that. So let's pretend that your angle between VS and VS and VR is not 90 degrees, so some angle alpha. And anyway, we need to establish the length of the side, which is V resultant. Okay, so you know that's 35, you know that's 5, so find the value for V res. If alpha is not 90 degrees, so it's other angle, so your triangle is not right angle. How to do in this case? So I'll give you the hint. That's here you need to use cos rule for the triangle. So cos rule for basically scalene triangle. So basically it's for any triangle you can apply cos rule. How this rule works? So if you know two sides and the angle between them, and you want to find the opposite side, the opposed to the angle, so you simply need to use the following rule. So the opposite side squared is the sum of the squares for two other sides, in this case that one, and you subtract double product VS VR by the cosine of the angle. So that's why this rule is called cos. So an angle should be between those sides, so here and here, that's your angle. Okay, so look guys, that's almost Pythagoras, but here is sort of adjustment. but the double product by and also by cos alpha between them and the angle between them. So how this rule to memorize? You remember the formula. So if we try to have some analogy and comparison, so we can set up A, B, and C, right? And this side is C in the triangle. And remember, we have the formula that looks like A plus B, sorry, A minus B squared. So what is that? It's the difference, the square of the difference. How it works? It works like A squared, then plus B squared, and minus 2AB. Look guys, you have almost the same. So you have two sides, which is VS, VR. So let's compare it with the picture. Yes, so that side is A and B. And here is the square, the sum of the square, which you have here. And then you subtract minus double product of those sides. So double product of those sides. However, this formula ends up here, while cos rule need to have cos alpha as extra factor. So if you multiply by cos alpha, for this formula, you'll get your cos theorem, okay, for the opposite side. And that will be equal to c squared. So you can use that analogy in order to memorize this formula. Okay, so do we have enough data? Yes, of course. If we know the angle between two sides and we know the sides, we can always find the opposite side, which is simply can be calculated using this formula. So I put this as very significant, and we'll try to see how this formula works in the real problem. Hope you like that. We've covered it's not real complicated, but it takes, you see, more passion in order to figure out and do all steps correctly. So, but I hope that you've got the main idea how it works. So I advise you to go through typical tasks, probably find it in past papers, and only then you'll succeed. Okay? Don't forget to subscribe, guys. That was Daniel Dallas. See you later.